the ground underneath Naples moved sideways, not slowly the way it has been rising for 21 years, sideways, in seconds, on the last night of July, about a centimetre across the middle of the caldera, 3 centimetres at the one station sitting directly on top of the most dangerous piece of ground in Europe, and it dropped at the same time by 1 to 2 centimetres. That has never been recorded here before, but the measurement is not the strange part. The strange part arrived 3 weeks later, when the scientists finished recalculating and published what the volcano had done in the days afterwards. And the answer was nothing. Nothing at all. Which sounds like reassurance, and is very nearly the opposite. Before we go any further, if you enjoy what we do here at Project Nightwatch, hit like and subscribe so you don't miss any of our nightly debriefs, and drop a comment and tell me where you're watching from tonight. Now, let's get into it. Part 1. The number that should not be there. There is a line in a monitoring bulletin published on the 18th of August 2026 that describes something the ground beneath Naples has never been recorded doing before. It is not a dramatic line. It does not contain the word eruption. It does not contain a warning or an alert or an evacuation instruction. It is a technical sentence about satellite positioning data, written in the flat institutional Italian that these documents are always written in, and it says that during the earthquake swarm of the 31st of July, several of the permanent monitoring stations inside the central area of the Campi Flegrei caldera recorded what the bulletin calls co-seismic discontinuities, on both the horizontal components and on the vertical. Here is what that sentence actually means. The ground moved sideways, and then it dropped. I want to be very precise about the numbers, because the precision is the whole story. The stations in the central area of the caldera recorded a horizontal displacement of approximately 1 centimetre, plus or minus 0.2, in a predominantly southwest direction. One station recorded something different. The station at Rione Terra, in the middle of Pozzuoli, at the exact point where this caldera has been rising fastest for 21 years, recorded a horizontal displacement of approximately 3 centimetres, plus or minus 0.2, in a south-southwest direction. And the same set of stations recorded a lowering, a subsidence, averaging approximately 1 to 2 centimetres, plus or minus 0.2. That is the finding. A block of the most closely watched volcanic ground on the planet moved seaward and settled downward, permanently enough for the instruments to record it as a step rather than as noise in the space of a few seconds on the last night of July. And the reason I am opening with the number rather than building up to it is that the number is not the surprising part. The surprising part comes later, and it is not a thing that happened. It is a thing that didn't. Let me set the scene properly, because if you have never stood in Pozzuoli, it is hard to picture what we're talking about. Campi Flegrei is not a mountain. There is no cone, no crater you can point at from the motorway, no snow-capped summit with a plume drifting off the top. It is a caldera, roughly 12 to 15 kilometres across, and the town of Pozzuoli sits inside it. So do the western suburbs of Naples. So do the roads, the schools, the churches, the railway lines, the harbour, the apartment blocks, the market stalls, the football pitches, and something on the order of 500,000 people inside the officially designated red zone alone, with millions more in the greater metropolitan area beyond it. When people say a supervolcano, they picture something distant and geological. This one has a bus timetable, and since November 2005 the floor of that caldera has been going up, not quickly, not in a way you would notice standing on it. The technical word for this is bradyseism, from the Greek for slow shaking, and it describes exactly what it sounds like. A caldera floor that rises and falls over years and decades rather than seconds. The current rise began in November 2005, and it has not stopped since. It has sped up, it has slowed down, it has produced earthquake swarms and gas crises and evacuations and political arguments, but the direction has been the same for 21 years. Up. Which is what makes a sideways step so strange. Because a co-seismic discontinuity is a completely different animal from bradyseism. Bradyseism is slow, continuous, and dominantly vertical. It is the caldera floor inflating millimetre by millimetre, month after month, because something underneath it is pushing. A co-seismic discontinuity is instantaneous, and in this case it was dominantly horizontal. It is not the volcano inflating, it is the crust snapping. One of these processes is a bulge, the other is a break. and as of the 18th of August, both of them are sitting in the same dataset, at the same volcano in the same year, pointing in different directions. It is worth being concrete about the event itself, because everything in this video hangs off it. On the evening of the 31st of July, 2026, at 7:45 local time, a magnitude 4.7 earthquake struck about 3 kilometres beneath the Solfatara area, a few kilometres east of the centre of Pozzuoli and around 9 kilometres west of Naples. It was the strongest earthquake ever recorded at this caldera since dedicated instrumental monitoring of the system began, and the strongest felt in the region of Campania in roughly 4 decades. It was followed by a swarm that ran through the night. In the month of July as a whole, the caldera logged 426 earthquakes, and it broke things. Not in the way a great subduction earthquake breaks things. There was no tsunami, no collapsed motorway, no city flattened. It broke things the way a moderate earthquake breaks a town built out of old masonry that has been shaken for years without ever being repaired properly. Facades came down, boulders came off slopes and landed on parked cars. Walls that had been cracked and patched and cracked again finally stopped being walls. 3 weeks later, 215 buildings in Pozzuoli stand condemned, and we will get to what that has done to the people who lived in them. But the buildings are not why this event is scientifically interesting. Buildings tell you about mortar, the instruments tell you about the volcano, and what the instruments recorded is a caldera that changed shape. I should explain how we even know this, because the answer is genuinely remarkable, and it feeds directly into why this measurement matters. Campi Flegrei is monitored by a permanent network of what are called GNSS stations. That stands for Global Navigation Satellite System, and in practice it means a receiver, bolted or cemented into bedrock, that continuously listens to positioning satellites overhead and works out exactly where it is in 3 dimensions, over and over, all day, every day, for years. Set one of these up and leave it alone, and it will draw you a graph of the ground it sits on. Not a graph of what happened to the ground, a graph of the ground itself moving. There are people who have been reading those graphs for 2 decades. They know what the normal wobble looks like. They know what the seasonal noise looks like. They know what a bad satellite pass looks like and what a settling monument looks like, and what atmospheric water vapour does to the vertical component on a humid afternoon in July. And when the 31st of July arrived, the trace on several of those stations did something none of that explains. It jumped, and it stayed jumped. So the numbers are not an estimate from a model. They are not a simulation. They are not an inference from the shaking. They are a before and after position measurement on physical objects that are attached to the ground, and the difference between the before and the after is 1 centimetre for most of them, and 3 centimetres for one of them. Now, 1 centimetre. I know how that sounds. It is the width of a fingernail, it is nothing. You could lose a centimetre stepping off a curb, and in almost any other context, on almost any other piece of ground on Earth, you would be right to shrug at it. But this is not almost any other piece of ground. This is a caldera in the 21st year of an unrest episode, sitting over a hydrothermal system that has been measurably heating and pressurizing for years, above a magma body that scientific papers have been arguing about with increasing urgency, underneath a city. On that ground, a permanent 1 centimetre offset is not a rounding error. It is a piece of evidence about what the rock is doing, and it is one of very few pieces of evidence any of us are ever going to get. And there is one more thing about that number I want you to hold on to before we go any further, because it is the detail that reframes everything that follows. Most of the caldera moved about 1 centimetre. Rione Terra moved 3. That is a factor of 3 between one station and its neighbours, on a network that sits within a few kilometres of itself. That is not uniform ground motion. That is a caldera floor that did not move as a single rigid slab, that had a piece which travelled further than the rest of it, in a consistent direction, and dropped. So what broke? And why did the ground above the point of maximum deformation move furthest of all? Part 2. How you measure a centimetre from space. To understand what those instruments recorded, you have to understand what they are actually doing, and it is one of the more quietly astonishing pieces of routine science on this planet. A GNSS receiver does not simply pick up a satellite and read off a position, the way the navigation app in your car does. Your phone is happy with a few meters of accuracy, because a few meters is enough to tell you which junction to take. A permanent geodetic station is doing something much harder. It is tracking the carrier phase of the signals arriving from a dozen or more satellites at once, measuring the arrival of individual wave crests, and comparing them against models of the satellite orbits, the delay introduced by the ionosphere, the delay introduced by water vapor in the lower atmosphere, the tiny flexing of the solid Earth caused by the tides, and the position of every other station in the network. Run all of that through the processing chain, and you get a position in 3 dimensions, good to a few millimeters. Do that once, and it is a curiosity. Do it every day for 21 years, and you get a biography of the ground. That is why the Caldera Bulletin can casually publish a figure of 10 plus or minus 3 millimeters per month for the current uplift rate, and nobody blinks. That number exists because a network of receivers has been sitting in the rain in Pozzuoli, patiently for 2 decades, taking the same measurement over and over until the trend emerged from the noise, and the station that matters most in this story has a name worth remembering. It is called RITE, and it sits at Rione Terra. Rione Terra is the oldest part of Pozzuoli. It is a promontory of yellow tuff standing above the harbour, a rock outcrop with a Roman street plan carved into it, a cathedral built inside a Roman temple, and centuries of buildings stacked on top of one another. It was evacuated in the 1970s during an earlier phase of this same crisis, and it has been a place of archaeology and restoration ever since, and it happens to sit almost exactly on top of the point where the caldera floor is rising fastest. That is not a coincidence of geography. The deformation at Campi Flegrei has a shape. It is not a uniform lift across the whole caldera. It is a broad dome, highest in the centre, tapering toward the edges, and the centre of that dome sits under Pozzuoli. So when you want one number that describes the state of this volcano, you take the number from the station in the middle of the dome, and that station is Rione Terra. Every headline uplift figure you will ever hear about Campi Flegrei is, in practice, the RITE figure. Which brings us to what the bulletin means by a discontinuity. Imagine you are looking at that 21-year trace. Mostly it climbs, sometimes steeply, sometimes flattening off, with a faint sawtooth of seasonal noise riding on top. It is a curve. It is continuous. Every point connects to the next one. Now imagine that on one particular evening the trace does something a curve is not supposed to do. It stops. It jumps to a different value. And then it carries on climbing from the new value. That is a discontinuity, a step, and it is the geodetic signature of the ground having physically moved between one measurement and the next, rather than having drifted there gradually. The reason it matters that the bulletin reports discontinuities on both the planimetric and the vertical components is that those two things tell you different stories about what happened. Planimetric means the horizontal, the north and east part of the position, the map view. Vertical is the up and down. A pure inflation event pushes the vertical up and pushes the horizontal outward, radially, away from the centre, the surface of a balloon expanding. What was recorded on the 31st of July was not that. The horizontal motion was in a consistent southwest sense across the central stations, and the vertical went down, out and down, not out and up. Then there is the error bar, and I want to spend a moment on it because it is doing real work here. Every one of those figures is published as plus or minus 0.2 centimetres. That is the stated uncertainty on the measurement, and what that tells you, immediately, is the difference in quality between the two signals. At 1 centimetre, an uncertainty of 0.2 is 20% of the value. Real, but not enormous. At 3 centimetres, the same absolute uncertainty is under 7%. In other words, the Rione Terra offset is not just the biggest of the set. It is the most statistically solid of the set. The one measurement in this whole story you would least want to argue with is the one that says the ground under the oldest part of Pozzuoli moved 3 centimetres toward the sea. And the GNSS network is only one instrument among many, which is the thing that earns Campi Flegrei its reputation. When people say this is one of the most monitored volcanoes on Earth, they are not being loose with the phrase. There is a permanent seismic network, dense enough that the reviewed solution for the 31st of July event drew on more than 20 stations and produced a horizontal location, uncertainty measured in hundreds of meters, for an earthquake 3 kilometers down under a city. There are tilt meters, which measure the ground tipping rather than rising. There is repeated levelling, the old-fashioned optical surveying method, still run as an independent check on the satellite data. There is interferometric radar from orbit, which images the deformation of the whole caldera as a pattern rather than a set of points. And then there is the chemistry, which at this volcano matters as much as the physics. There are permanent stations measuring the temperature of the fumaroles. the steam vents at Solfatara and at Picciarelli, where the hydrothermal system reaches the surface. In the reference week of this bulletin, the fumarole temperature averaged around 95 degrees Celsius, which is essentially the condensation temperature of the fumarolic fluid, and the sensor at the newer Solfatara station read around 173 degrees. There are stations measuring how much carbon dioxide is diffusing out of the soil across the crater floor. There are laboratories analysing the isotopic composition of the gas, because the ratio of one sulfur isotope to another can distinguish gas that has come from a deep magma body from gas that has merely been cooked out of the rocks. All of that is running continuously and published weekly. So when a step appears in the GNSS record, it is not appearing in isolation. It is appearing inside a monitoring picture that includes seismicity, tilt, gas chemistry, gas flux, ground temperature and satellite imaging, all of which can be cross-checked against it. That is why a 1 centimetre offset can be stated as a finding rather than as a maybe, and it is why the absence of any corresponding change elsewhere in that picture is itself a piece of information. There is a related distinction in the same bulletin that is worth explaining, because it prevents a lot of misreading elsewhere. In the monitoring week of the 10th to the 16th of August 2026, the caldera recorded 43 earthquakes. 23 of them were located. People see those two numbers and assume the difference is something being hidden. It is not. Recording an earthquake means an instrument saw a wiggle. Locating an earthquake means enough instruments saw a clean enough signal at precise enough times that a computer could triangulate a hypocenter out of the arrival times. Very small events, or events that happen while a bigger one is still ringing, produce a trace that is real but not sharp enough to place. So they are counted, and they are honestly published as counted but not located, which is a great deal more transparent than quietly dropping them. And that same instinct towards stating the limits of the measurement is exactly what produced the sentence in the 18th of August bulletin that most people skipped over, the one that says these values are not final. Part 3. 3 weeks of recalculation. The figures I have just given you are the third version. That is not a criticism. It is how this work is supposed to go, and following the chain is genuinely useful, because it shows you an institution doing the unglamorous thing in public. The earthquake happened on the evening of the 31st of July. The first weekly bulletin after it, published on the 4th of August, reported that co-seismic discontinuities had appeared in the GNSS time series. The bulletin published on the 11th of August reported them again. The monthly bulletin covering July, the month in which the caldera recorded 426 earthquakes with a maximum magnitude of 4.7 plus or minus 0.3, reported them as well. Then, with more data in hand, the numbers were recalculated, and the bulletin published on the 18th of August states that the recalculated values substantially confirm what had already been reported. Now, why would you need to recalculate a position measurement? The satellites did not move. The receivers did not move. The event is over. What is there left to compute? The answer is that the position of a GNSS station is not a raw observation. It is the output of a calculation, and one of the largest inputs to that calculation is where the satellites were at the moment the signal left them, and that is not perfectly known in real time. Satellite orbits are broadcast in near real time as predictions. They are good enough for a phone, good enough for a first-pass geodetic solution, but they are predictions, and predictions have errors. In the days and weeks afterwards, the International Analysis Centres go back through the tracking data from ground stations all over the world and compute what the orbits actually were. Those are the final orbital products, feed them back into the processing, along with better models of atmospheric delay and better estimates of every station's behaviour, and every position in the archive gets a little more accurate. So the sequence at Campi Flegrei was measure the step immediately, publish it immediately with the caveat that it is preliminary, then refine it as the orbits firm up. 3 passes over 3 weeks, and the third pass agreed with the first 2. The bulletin of the 18th of August is explicit that even this is not the end. It states that the definitive estimate of the discontinuity values will be recalculated again, as more results from scientific software processing and final orbital products become available, and that those definitive values will appear in the next monthly bulletin, the one for August. I want to sit on that for a second, because it is the most checkable thing in this entire story. A named institution has publicly committed to publishing a specific number in a specific document on a known schedule. It has told you in advance what the number is about, roughly what it currently looks like, and why it might shift. If you want a way to follow this story that does not depend on anybody's interpretation, mine included, that is it. The August monthly bulletin either confirms 1 centimetre and 3 centimetres, or it does not, and either way you will know. That kind of forward commitment is also, incidentally, the fastest way to test a claim you're going to hear a lot in this video, that the people monitoring this volcano are hiding what it is doing. Institutions that hide things do not schedule the publication of the numbers that would expose them. It is also worth understanding what these bulletins are because they are not press releases. They come out on a fixed weekly schedule, and a longer one comes out monthly, and they have the same sections every time in the same order: seismicity, ground deformation, geochemistry, and then a closing assessment. They contain the numbers whether the numbers are interesting or not. In a quiet week, the seismicity section says something like 8 earthquakes were located, maximum magnitude 0.8, and that is the whole entry. The week we are discussing was not quiet, but it was not extraordinary either. Between the 10th and the 16th of August, 2026, 23 earthquakes were located out of 43 recorded, with a maximum magnitude of 3.4. The week before, 22 had been located, and from 27 minutes past 2 in the morning on the 10th of August, a swarm of 10 earthquakes was recorded, maximum magnitude 3.4, in the area between Pozzuoli and the Garrow crater. That is the ordinary rhythm of this place now. 10 earthquakes in a swarm, in the middle of the night, one of them at magnitude 3.4, in a town where 215 buildings are already condemned. It is a line in a bulletin. It is also somebody's 4th sleepless night in a row. The closing assessment in that same bulletin is the standing formulation this institution has used for a long time now. On the basis of the current picture of volcanic activity, no elements are evident such as to suggest significant short-term evolutions. We are going to take that sentence apart later, because it is doing a great deal more work than it appears to be doing, and because it is the single line that makes people in Pozzuoli angriest. There is a second sentence in the same section that is easy to skim past and much harder to unhear once you have understood it. It concerns what happened to the underlying trend once the step was accounted for. When you find a discontinuity in a time series, the standard procedure is to correct for it. You take the step out, you shift everything after the jump back by the size of the jump, and what you are left with is the underlying behaviour of the system with the instantaneous event removed. It is the geodetic equivalent of subtracting a known interference so you can see the signal underneath. They did that. They took the 1 centimetre out of the central stations and the 3 centimetres out of Rione Terra and the 1 to 2 centimetre drop out of the vertical, using the updated values, and looked at what the caldera had been doing before and after the largest earthquake ever recorded on it. And the bulletin's finding, in its own careful wording, is that from the corrected time series, no significant changes in the deformation patterns are evident following the seismic event and the associated swarm. That is the sentence. That is the thing I have been building toward since the first minute of this video, not what the caldera did during the earthquake, what it did afterwards. Part 4. The thing that didn't happen. Something enormous happened at Campi Flegrei on the 31st of July, and the deformation of the caldera did not react to it at all. Sit with the strangeness of that for a moment, because our instincts about volcanoes and earthquakes push very hard in the opposite direction. We expect systems to respond. We expect the biggest event in the instrumental record of a volcano to leave a mark on that volcano's behaviour. Something should be different afterwards. Faster, slower, tilted, reversed. Something. Nothing was different. The line went back to what it was doing. There was a specific version of this expectation circulating in the days after the earthquake, and it was a hopeful one, so it spread quickly. The reasoning went like this. This caldera has been building up pressure for 21 years. It has just released the largest amount of seismic energy it has ever been recorded releasing. Surely that relieved something. Surely the ground, having been pushed up for 2 decades, would now settle back. Surely the uplift would reverse, or at the very least stall, and the crisis would begin to wind down. You can see why people wanted that to be true. 3,500 of them were out of their homes. But it is not what happened, and there are 2 separate reasons to be confident about that. One from this event, and one from the history of this crisis. The reason from this event is the corrected time series. Once the step is removed, the deformation pattern after the earthquake shows no significant change from the trend of the preceding months. The uplift did not reverse, It did not stop. It did not visibly slow. It kept going at approximately 10 plus or minus 3 millimeters per month in the zone of maximum deformation, which is roughly the rate it had been running at since the beginning of February 2026. The reason from history is even more direct. The 31st of July was not the first magnitude 4 earthquake of this crisis. It was not the second or the third. There has been a whole ladder of them over the past couple of years, each one at the time described as the strongest in decades, each one followed by the same speculation that the pressure had been released. Not one of them reversed the uplift. In several cases, the uplift continued straight through the event without so much as a stumble, and in some analyses it appeared to pick up afterwards rather than ease. So we have a system that has now been given, repeatedly, the exact stimulus that people keep expecting to calm it down, and it has responded by carrying on. I want to be careful here, because there is a version of this observation that is genuinely alarmist and wrong, and a version that is genuinely important and true, and they sound similar if you're not paying attention. The wrong version is, the earthquake did nothing to relieve the pressure, therefore the pressure is still building, therefore we are closer to an eruption than we were. That chain has a broken link in it. Nothing in the bulletin says magma has moved. Nothing in it says the system is approaching an eruption. The alert level was not raised, and the standing institutional formulation is that no elements are evident such as to suggest significant short-term evolutions. The right version is quieter and harder to dismiss. It is this. If a large earthquake in the shallow crust does not change the deformation, then the deformation is not being produced by stress stored in the shallow crust. It is being produced by something else, somewhere else, that the earthquake could not reach. And that is an enormous thing to be able to say about a volcano, because it narrows the field. Think about what the alternatives were. If the uplift had been elastic strain accumulating in the rock, the crust bending like a plank under load, then breaking the plank should release it. That is what elastic means. Store energy, deform, break, spring back. The vertical did spring back a little, by 1 to 2 centimetres, at the moment of the rupture. But the 21-year trend did not care. It absorbed the release and carried on climbing at the same rate. The alternative, and the one this observation supports, is that the caldera is being lifted from below by something that is still supplying. Fluids, gas, heat, magma at depth driving all three. In that picture, the earthquake was a failure in the material above the source, and the source did not notice. Here is the analogy I keep coming back to, and I am going to use it once and then let it go. Imagine a car with the engine running and the bonnet closed, and the bonnet is buckling upward because something underneath is pushing. Then the metal tears. There is a bang. The bonnet drops a centimetre where the tear opened up and shifts sideways as the panel relaxes. Has the engine stopped? No. The engine has not been touched. The engine does not know the bonnet tore. And 30 seconds later the panel starts buckling again, because the thing that was pushing is still pushing. That is what the 18th of August bulletin describes. The roof cracked. The engine kept running. There is a second strand of evidence pointing the same way, and it comes from the chemistry rather than the geodesy. In the same reference week, the stations measuring diffuse carbon dioxide flux out of the soil at Solfatara and at Picciarelli recorded a slight decrease, on the order of 15 to 20%. On its own, that sounds like good news. Less gas coming out. Something easing. But a weekly gas measurement at a hydrothermal system is a noisy thing. It responds to rainfall, to barometric pressure, to soil moisture, to the temperature of the air above the ground. A 15 to 20% wobble over a week is not a trend, and the standing characterization of this system, the one that has not changed through any of it, is that the geochemical parameters continue to indicate a long-term heating and pressurization of the hydrothermal system, with elevated emission of volcanic fluids. So you have the same structure appearing twice, in two completely independent datasets. In the deformation, a short-term event, then the long-term trend continuing unchanged. In the chemistry, a short-term dip inside a long-term trend of heating and pressurization. Two different measurement systems run by different specialists, measuring different physical quantities, both saying the same thing. The weather changed, the climate did not. The rate history deserves the same treatment, because it is the most commonly misread number in this entire crisis. From the middle of December 2025, the uplift velocity in the zone of maximum deformation was recorded at approximately 15 plus or minus 3 millimeters per month. From the beginning of February 2026, it was approximately 10 plus or minus 3 millimeters per month. So the rate came down by roughly a third. Every time that happens, two opposite stories get told about it. One says the volcano is calming down, the other says the slowdown is a sign the system is jamming up before something worse. Both of them are overreading a pair of numbers whose error ranges very nearly touch. 15 minus 3 is 12, 10 plus 3 is 13. The bands overlap. There is a real decrease there, but it is a decrease within a system that over the long run has been described as following a broadly parabolic path with an average acceleration on the order of 0.7 to 0.8 centimetres per year squared. That is the thing to hold on to. A curve that accelerates over decades can absolutely have months where it slows, and that is not a contradiction. It is what a noisy parabola looks like when you sample it monthly. The month-to-month rate tells you about this month. The 21-year shape tells you about the volcano, and the 21-year shape did not blink on the 31st of July. Now, the fair objection to all of this is that we are reading a great deal into 3 weeks of data with error bars on it, and that objection is correct. A monthly uplift rate of 10 plus or minus 3 millimeters has an enormous amount of room inside it. A change from 10 to 8 or 10 to 12 would sit comfortably inside the noise and nobody could honestly call it a change. What the bulletin says is that no significant change is evident, significant being the operative word, and significance in this business meaning distinguishable from the wobble. So the honest formulation is not, the earthquake definitely did nothing to the deformation. It is, whatever it did was small enough to hide inside the ordinary month-to-month variation of a system that has been rising for 21 years, which, for an event that was the largest ever recorded at this caldera, is a remarkable statement about how disconnected the two things are. And it raises the question that Act 2 is really about. If the earthquake did not touch the engine, then what exactly did it touch? And why did the piece of ground directly above the engine move 3 times further than everything around it? Part 5. Down. During, up before, up after. Let me do the arithmetic on the vertical, because when you put the two numbers side by side, something quite strange falls out of them. During the earthquake, the central stations dropped by an average of 1 to 2 centimetres. Since the beginning of February, the caldera has been rising at approximately 1 centimetre a month. So the amount the ground fell during the largest earthquake ever recorded at this volcano was equivalent to somewhere between 1 and 2 months of ordinary uplift. That is the whole size of it. The event took back 1 to 2 months, and the earthquake was on the 31st of July. As I record this, it is the 22nd of August. 3 weeks have passed. At a centimetre a month, the caldera has already put back roughly 7 millimetres of what it lost, and by the end of September, on current rates, the drop will have been fully erased and the ground will stand higher than it did before the earthquake. That is not a metaphor. That is just the two published numbers divided into each other. I find this the single most clarifying fact in the whole story, because it puts the earthquake in proportion without diminishing it. The event was violent, it was destructive, it condemned buildings and displaced thousands of people, and it was, by magnitude, unprecedented in the instrumental record of this caldera. And in terms of the actual shape of the ground, its permanent vertical effect amounts to about 6 weeks of a process that has been running for 21 years. Which means the process is the story, not the earthquake. So let us look at the process properly, because the numbers on it are genuinely difficult to hold in your head. The current uplift phase began in November 2005. That is the start of the clock. Since then, the ground at Rione Terra has risen by more than 1.5 meters. At the end of March 2026, the figure quoted for the current phase was approximately 163.5 centimetres. Add roughly a centimetre a month for the 4.5 months since, and you are somewhere in the region of 168 centimetres by now, though I will flag clearly that this last step is my arithmetic, and not a published figure. The precise current total will be stated in the August monthly bulletin. 168 centimetres, 5.5 feet, the height of a person. If you had been standing at Rione Terra in November 2005 and you had somehow stayed standing there, the ground would now have carried you up by roughly your own height. The harbour below you would be further down than it was. The sea would be further away in the vertical sense that matters to a boat, and you would not have felt a single centimetre of it happen. Now here is the part that shows how fast the recent phase has been. of that entire 21-year rise, approximately 30.5 centimetres has arrived since January 2025. That figure comes straight out of the 18th of August bulletin, and it had been approximately 30 centimetres in the previous week's bulletin. You can watch it tick up week over week if you read them. So somewhere around a fifth of the total uplift of the past 21 years has happened in the last 20 months. That is the shape of an accelerating system, and it is why the technical description of the long-term trend is broadly parabolic, with an average acceleration on the order of 0.7 to 0.8 centimetres per year squared, rather than a straight line. A straight line would mean the caldera is being lifted at a constant rate by a constant supply. A parabola means the rate itself is increasing over time, but, and this is where people fall over, a parabola with noise on it does not go up smoothly, it goes up in fits. There are months where it flattens, there are months where it surges. The mid-December figure of 15 millimetres a month and the February figure of 10 millimetres a month are both real measurements, and the fact that the second is lower than the first does not tell you the parabola has stopped being a parabola. It tells you that you are sampling a noisy signal at monthly resolution, and the noise is comparable to the change. And this caldera has done all of this before, which is the only reason anybody knows what to make of it. In the early 1980s, Pozzuoli went through a bradyseismic crisis that in some respects was sharper than the current one. The ground rose by close to 2 metres in the space of about 2 years. More than 16,000 earthquakes were recorded. Tens of thousands of people were moved out of the old town. Figures in the range of 30 to 40,000 are the ones usually quoted, and a whole new district was built inland to house them. Rione Terra itself was condemned and emptied in that era, and has never been fully reoccupied since. And then it stopped. The ground went back down. Between the mid-1980s and the mid-2000s, the caldera subsided by the better part of a metre, quietly, without erupting, and the crisis ended not with a bang but with a long shrug. That is the single most important piece of context anybody in Pozzuoli carries, and it cuts both ways. It is the reason to hope, because it is direct evidence that this caldera can inflate dramatically and then simply stop. It is also the reason for the exhaustion, because the people who lived through that one are living through this one, and this one has now been going for 4 times as long. There is an older record too, and it is one of the most elegant pieces of evidence in geology. The Roman marketplace at Pozzuoli, long miscalled the Temple of Serapis, has 3 standing marble columns, and partway up each of them is a band of holes drilled by marine mollusks. Those animals only bore into stone below sea level, which means that after the Romans built it, the ground sank far enough to put the middle of those columns underwater, and then rose again far enough to lift them back out. Nobody had to infer that from a model. The evidence is drilled into the marble, so the current uplift is not an aberration in the life of this caldera. It is what this caldera does. The question has never been whether the ground moves. It is what the movement is a symptom of this time. There is a version of this confusion I want to address directly, because it recurs constantly around this volcano, and it makes people distrust the science for no good reason. You will find perfectly serious commentary saying the uplift is decelerating. You will find equally serious commentary saying it is accelerating, and both can cite real numbers. The reconciliation is simply that they are talking about different windows. Over a few months the rate has come down. Over 2 decades the envelope has been curving upward. Neither observation refutes the other, any more than a cold week in July refutes a warming summer. Where it becomes genuinely important is here. If you only look at the short window, you get the pleasant reading. The rate is falling, the crisis is winding down, the earthquake was the peak. If you only look at the long window, you get the alarming one. This thing is accelerating and has been for 20 years, and what actually happened on the 31st of July is a data point that belongs to neither window and cuts across both. Because the earthquake happened during the slow phase, that is worth saying again. The strongest earthquake ever recorded at Campi Flegrei occurred at a moment when the ground was rising more slowly than it had been 6 months earlier. The push, by the only measure we have of it, was weaker than it had recently been, and the rock broke anyway. There is only one straightforward way to explain that. If the load did not increase, then the strength must have decreased. Something in the rock gave way at a lower load than it would have withstood a year ago because the rock itself has been degraded, fractured and refractured again and again by 20 years of being bent. And that idea, that the thing changing is the strength of the material rather than the size of the force, is exactly what makes the horizontal measurement so interesting. because a rock that is losing its strength does not fail evenly. It fails where it is weakest, which brings us to the one station that did not behave like the others. Part 6. Why Rione Terra moved 3 times. As far. 1 centimetre across the central caldera. 3 centimetres at Rione Terra. There is no version of that where the ground moved as a single solid block. If a rigid slab shifts, every point on it shifts by the same amount. What was recorded on the 31st of July was a caldera floor in which one patch travelled roughly 3 times further than its neighbours over a distance of a few kilometres, and every one of those instruments is sitting within sight of the others. And it was not a random scatter either. That is the part that rules out a lot of otherwise reasonable explanations. If the pattern had been a centimetre here, 3 centimetres there, half a centimetre somewhere else, all pointing in different directions, you would suspect the instruments, or local ground effects, or the processing. It was not like that. The central stations moved southwest consistently. Rione Terra moved south-southwest. Same broad sense, same broad direction, different magnitude. That is coherent motion of a deforming body, not noise. Part of the caldera floor moved toward the Gulf of Pozzuoli, and the part closest to the middle of the dome moved furthest. So why that station? There are 2 candidate explanations that I think are worth putting in front of you. Both are speculation, and I'm going to label them as such every step of the way, because neither has been published as a finding, and I am not going to present my reasoning as somebody else's conclusion. But they are the 2 obvious readings, and the difference between them matters. The first is the simple one: proximity. In any earthquake, the ground offset is largest close to the fault that slipped and falls away with distance. If a structure ruptured beneath the central caldera and Rione Terra happened to sit nearest to it, then Rione Terra recorded the largest offset for the most boring possible reason. Under this reading, the 3 centimetre figure is a distance measurement in disguise. It is telling you roughly where the slip happened. The second is more interesting, and it has to do with what Rione Terra actually is. Rione Terra is not soft ground. It is a promontory of yellow tuff, welded volcanic ash, compacted into rock, standing up above the harbour as a headland. It has been a defensible high point since before the Romans built a colony on it, and its street plan is still Roman underneath the later town. Geologically, it is a coherent, mechanically strong block sitting in the middle of a caldera floor that is not uniformly coherent or uniformly strong, and a strong block embedded in weaker material behaves differently under stress. It can move as a unit where the surrounding ground deforms internally and absorbs part of the motion. It can be bounded by structures, old fractures, the edges of the block itself, that concentrate slip along its margins. If that is what is going on, then the 3 centimetres is not primarily telling you where the fault was. It is telling you that Rione Terra is a distinct structural piece of this caldera, and that it moved as one. These 2 readings are not mutually exclusive. It is entirely possible that the structure which slipped runs close to the edge of that block, in which case both explanations are describing the same geometry from different angles. What would separate them is not a bigger earthquake. It is a map. Specifically, a high-precision relocated catalogue of the earthquakes in that swarm, hypercenters recomputed to their tightest possible positions and plotted in 3 dimensions. If those points collapse onto a single plane that projects toward Rione Terra, the proximity explanation is doing the work. If they wrap around the margins of the block, the structural explanation is. That is a real, answerable scientific question, and it will be answered by patient reprocessing over months rather than by anything dramatic. It is worth explaining what a relocated catalogue actually involves, because it is the mechanism by which most of what we know about this caldera has been extracted, and it is not the sort of thing that makes the news. When an earthquake is first located, the calculation uses arrival times of waves at a set of stations and a model of how fast waves travel through the ground. Both have errors. The result is a point with a fuzz around it, sometimes a few hundred meters wide, sometimes more. Plot thousands of those points and you get a cloud. Clouds do not tell you about structures. Relocation is the process of sharpening that cloud. The core trick is that nearby earthquakes recorded at the same station have almost identical travel paths, so the errors in the velocity model largely cancel when you compare them to each other rather than locating each one on its own. Do this across a whole catalogue, with waveform matching to measure the arrival time differences to a fraction of a second, and the cloud collapses. Structures appear that were invisible before, planes, lines, gaps. That process is what has been quietly rewriting the picture of Campi Flegrei over the past few years. Relocated seismicity at this caldera has been resolving into something with a shape, an elliptical ring-like distribution bounding the seismically active volume, concentrated at roughly 2 to 4 kilometers depth. The northern edge of that ring in particular has been described as a long-lived structure and a preferential pathway, channeling fluids ascending from deeper levels toward the surface expressions we can see, the Solfatara, Picciarelli, the ground under Pozzuoli. So the caldera is not a formless blob that produces earthquakes at random, it has architecture. And the 31st of July happened inside that architecture, on a structure the relocation work had already begun to draw, which is why the surface offset matters so much. The relocations tell you where the rock is breaking. The GNSS offsets tell you what the breaking did to the ground above. Put them together and you have both ends of the same event, and that is a far stronger constraint than either on its own. Now the direction, because I think the direction has been underplayed everywhere I have seen this reported. Southwest. And at Rione Terra, south-southwest. From Pozzuoli, that is seaward. That is out toward the Gulf. The caldera floor did not move randomly, and it did not move inland. It moved toward the water and down. I want to be careful not to oversell this, because there is a straightforward and unspectacular explanation available. Extensional faulting, the kind previously determined for the 31st of July event, rock pulling apart rather than being squeezed together, produces exactly this signature. One side of the fault slides down and outward relative to the other. Down and outward, at a caldera whose centre of deformation sits under the coastline, means down and seaward. That is textbook. But it is worth holding the geometry in your head, because Campi Flegrei does not stop at the shoreline. Roughly half of this caldera is underwater. The Gulf of Pozzuoli is not a bay next to the volcano. It is part of the volcano, drowned. The deformation dome, the seismicity, the structural boundaries, all of them continue offshore, where there are no GNSS stations bolted into the ground, and no buildings to be condemned, and therefore very little to tell us what is happening. So when the instruments on land record a coherent motion toward the water, they are recording motion toward the half of the system we cannot watch nearly as well. I am not going to build a scenario on that. Nothing in the bulletin suggests offshore movement is a new hazard, and speculating about submarine anything without data is exactly the sort of thing this channel tries not to do. But it is a fact about the geometry of this place that the best instrumented part of the caldera is the part that is dry, and the direction of travel on the 31st of July was away from it. There is one more thing that the 3 centimetre offset does, and it is the reason it will end up in papers rather than just in bulletins. It gives the earthquake a physical footprint on the surface. Up to now, almost everything we know about the events at this caldera comes from seismometers and from the slow accumulation of deformation. The seismometer tells you an earthquake happened, how big it was, and roughly where. The GNSS trend tells you the ground is rising. Neither of them tells you what a single earthquake did to the shape of the ground. This one does. For the first time in this crisis, there is a measured, published permanent change in the position of the caldera floor attributable to one event. That is a boundary condition. Any model that wants to explain the 31st of July now has to reproduce 1 centimetre southwest, across the central stations, 3 centimetres south-southwest at Rione Terra, and 1 to 2 centimetres of drop. Models that cannot do that are wrong, which means we are about to learn something, and it brings us to the question underneath all of it: what actually broke? Part 7. The roof and the engine. Everything we have looked at so far points toward the same conclusion, and it is time to state it plainly. The 31st of July was a failure in the roof of this volcanic system. It was not an event in the reservoir underneath it. Let me build that up piece by piece, because it is the intellectual core of this video, and it deserves to be earned rather than asserted. Start with what kind of source produced the earthquake. When an earthquake happens, you can work out from the pattern of ground motion recorded around it what sort of motion at the source would produce that pattern. This is routine, it is automatic, and it distinguishes between fundamentally different things. Rock sliding past rock along a fracture gives you one signature. A cavity inflating or deflating, a volume change, magma or gas forcing space open, gives you a completely different one. For the 31st of July, the determination was normal faulting, extensional, rock pulling apart and one block sliding down relative to the other, with essentially no volume change component at all. That single result does an enormous amount of work. It means the earthquake was not magma arriving. It was not a chamber inflating. It was not an explosion at depth. It was the crust breaking under tension, in the way crust does when it has been stretched. Now at the depth, around 3 kilometres. 3 kilometres, at this caldera, is a specific and meaningful place. The current picture of the system, built up over years from earthquake locations, from seismic imaging of how fast waves travel through different layers, and from the chemistry of what comes out of the ground, describes a structure in layers. There is a gas-rich zone at depth. Above it, at roughly 1 to 2 kilometres, there is a mechanically strong layer, a caprock, a lid. And the great majority of the shallow seismicity of the past several years has been concentrated in and around that lid. That is where the roof and engine picture comes from, and it is not my invention. It is the framework the published work on this caldera has been converging on. Fluids and heat rise from depth. They accumulate beneath a layer that does not let them through easily. Pressure builds under the lid. The lid, being brittle, responds by cracking, and it has been cracking in ever greater numbers for years. Put those pieces together, and the 31st of July stops being mysterious and starts being almost predictable in hindsight. A brittle layer that has been under increasing pressure and progressive damage for years finally produced its largest failure yet. Extensional, because the lid is being stretched from below. Shallow, because that is where the lid is. Accompanied by a small permanent offset of the surface above it, because when a lid tears, the pieces move. And crucially, this is the part that closes the loop. A failure in the lid does nothing whatsoever to the supply underneath it. That is why the deformation did not change. The engine was never involved. The uplift is being driven by whatever is arriving from below, and whatever is arriving from below did not stop arriving because a fracture opened 3 kilometres up. There is a piece of published thinking that sits underneath all of this, and deserves to be stated on its own terms, because it is the framework that makes the past 5 years at Campi Flegrei make sense. The idea is that this caldera crossed a threshold, and that it crossed it around 2020. Before that threshold, the rock was behaving elastically. Elastic means recoverable. Push on a piece of rock and it bends. Stop pushing and it springs back. Elastic deformation stores energy and gives it back. A caldera in an elastic regime inflates as the pressure rises and deflates when the pressure falls, and the earthquakes it produces are relatively few, because the rock is coping. After that threshold, the rock is behaving inelastically. Inelastic means permanent. The material is no longer bending and recovering. It is breaking, and each break is a change that stays. In an inelastic regime, the deformation stops being fully reversible. The number of earthquakes climbs, and, this is the important part, the load required to break the rock keeps going down, because every fracture leaves the remaining material weaker than it was. The evidence marshalled for that transition is the earthquake counts themselves, and they are hard to argue with. Over recent years, the annual number of located events at this caldera has climbed through the hundreds, then over 1,000, then several thousand. That is not a system doing more of the same. That is a system whose response to the same input has fundamentally changed character, and it explains the thing we identified 2 parts ago that otherwise makes no sense: a record magnitude arriving during a slow phase of the uplift. In an elastic regime, bigger earthquakes require bigger pushes. In an inelastic regime, bigger earthquakes can arrive from the same push, or a smaller one, because the rock has less left to give. Which brings up the question everybody asks next, and which I want to handle carefully because the answer is unsatisfying, and the unsatisfying answer is the honest one. How big can they get? There has been published work attempting to put a ceiling on the magnitude this caldera can produce, and the values that have come out of that work sit in the region of magnitude 4.4, with the important caveat that the upper bound scenarios in those same analyses involve more than one structure activating together, which pushes the number higher. The 31st of July was a 4.7 on the duration scale used locally, and rather lower when measured by the moment released, which is a genuine technical distinction, and not a fudge. So the record was set, roughly, at the ceiling. Not far beyond it. Around it. What that tells you is that the ceiling estimates are not badly wrong. What it does not tell you is where the real ceiling is, because a ceiling derived from the size of individual fractures stops applying the moment several of them link up into something longer. And linkage is precisely what an inelastic regime produces, Microfractures joining into fractures, fractures joining into faults. Nobody has published a number for what a linked structure at this caldera could produce. The honest answer is that the ceiling is uncertain, that it depends on a geometry which is currently being assembled fracture by fracture, and that a magnitude 5 in this town, with this building stock, is the scenario local engineers and officials have been arguing about in public for years. Now I want to sit with the uncomfortable half of this, because there is one, and skipping it would be dishonest. The reassuring reading of everything I have just said goes like this. No magma moved, no volume change, no eruption signature. The alert level is unchanged. This was a structural event in the roof, and the roof breaking is not the volcano erupting. All of that is correct. The unreassuring reading uses exactly the same facts. It goes like this. A lid that is progressively fracturing is a lid that is progressively losing its ability to hold anything back. And there is a strand of published thinking on this caldera which points out, carefully in the flat language of journals, that a well-developed fracture system can provide a pathway. That fractures which form under a pressurized system may become preferential routes for fluids, and in principle for magma, to move upward through material that would otherwise have blocked them. That is not a prediction. Nobody has forecast an eruption at Campi Flegrei. No institution has raised the alert level, and the standing assessment remains that no elements are evident suggesting significant short-term evolutions. I want that on the record clearly, because the difference between a mechanism and a forecast is the difference between honest science communication and fear-mongering. But it does mean that the same event supports two readings that feel opposite and are both defensible. The roof cracking is not the eruption. The roof cracking is also not nothing, and this is where I think the honest position lands, and it is not a comfortable one. We now know more about what happened on the 31st of July than we knew about any previous event in this crisis. We know the mechanism, we know the depth, we know the surface offset in 3 dimensions with error bars. We know the deformation did not respond. That is a genuinely impressive amount of knowledge, and it was produced by exactly the kind of patient, boring, publicly documented monitoring that this caldera receives more of than almost anywhere on the planet. And that knowledge still does not tell us what stage of this we are in. It does not tell us whether the 31st of July was the release the system needed, a big crack that let some pressure out through the fractures and bought everyone a few more years. It does not tell us whether it was the beginning of the lid failing structurally. It does not tell us whether the next big event is in 2 months or 20 years. Those are not questions the instruments answer, and pretending otherwise would be a lie. What the instruments do answer is narrower and in its way more useful. They tell you what the system is doing right now, and what it did in response to the largest kick it has ever been given. It shrugged. The ground jumped a centimetre sideways and settled a centimetre and a half down, and then, over the following days, went back to rising at exactly the rate it had been rising at before, as though somebody had reset a clock that never actually stopped. There is a particular kind of unease that comes from watching something not react. If the caldera had responded, surged, reversed, changed character, you would at least know the earthquake mattered to it. Instead, the largest event in the recorded history of this volcano registered as a step to be corrected out of a time series, and underneath the step the same slow curve continued upward, indifferent. The rock broke. The thing pushing on the rock did not notice, and there is one institution whose job it is to translate all of this into a single colour that appears on a public web page and determines what, if anything, anybody has to do about it. That colour has not changed in 14 years, and in Pozzuoli right now, that fact is the source of more anger than the earthquake itself. Part 8. What the alert level actually says. The official alert level for Campi Flegrei is yellow. It has been yellow since 2012. It was yellow the day before the largest earthquake ever recorded at this caldera. It was yellow the day after, and it is yellow today. Yellow means attention. It is the level above the ordinary baseline and below the levels that trigger the serious machinery of evacuation planning. And in Pozzuoli right now, that unchanged colour is generating more fury than the earthquake did, so it is worth understanding exactly what it is and what it is not. An alert level is not a measurement. This is the thing that gets lost. A magnitude is a measurement. An uplift rate is a measurement. A carbon dioxide flux is a measurement. An alert level is a decision, an assessment made by people drawing on the measurements, about which set of prepared responses is currently appropriate. It answers the question, what should we be doing, not the question, what is the volcano doing? Which means an unchanged alert level is not a claim that nothing has changed. It is a claim that nothing has changed in a way that alters what the appropriate response is, and you can test that reading directly against the data, because both are public. Between the day before the earthquake and today, the deformation rate did not change, the alert-relevant geochemical trends did not change, and no signal appeared indicating magma moving toward the surface. 215 buildings were condemned. But building damage is not an input to a volcanic alert level. Volcanic alert levels are about the volcano. That is a defensible framework. It is also, if you are sleeping on a camp bed in a sports hall in Pozzuoli, an infuriating one, because from where you're standing, something very obviously changed. It also helps to know what the levels above yellow actually are, because the shape of the ladder explains a lot about the reluctance to climb it. The framework in use has 4 colours, and with the subphases 6 steps in total. Green is the base condition. Yellow, the current level, has a weaker and a stronger form and means attention. The system is out of equilibrium and is being watched more closely than normal. Above that sits orange, again with 2 grades, which corresponds to a system in serious disequilibrium. And above that sits red, the pre-eruptive level. Now look at what those steps are attached to on the ground. The national planning for this caldera provides for the evacuation of the red zone in a total of 72 hours, roughly 12 hours of preparation, 48 hours of staggered departure, and 12 hours of margin. The population of that red zone is on the order of 500,000 people. The plan assumes they leave along the existing road network, the narrow, winding, parked-up streets of the Phlegrean towns and the western suburbs of Naples, either independently or with assistance, and are received in partner regions elsewhere in Italy. 72 hours, 500,000 people, roads that struggle with a normal Friday. That is what an alert level change eventually leads to, and it is why a colour is not a communication tool. It is the first domino in a sequence that ends with a national logistical operation of a scale Italy has not attempted in modern times, which cuts both ways again, and I want to be fair about it. On one hand, that is a powerful reason for caution. You do not want to trigger a partial evacuation of a metropolitan area on an ambiguous signal, because false alarms have costs and worse, they burn public willingness to comply the next time. On the other hand, the plan requires the volcano to give 72 hours of unambiguous warning that it is not under any obligation to give. A phreatic explosion, a steam blast driven by the hydrothermal system rather than by rising magma, is the scenario most often raised as the one that could arrive without a long clear run-up, and that is the box everybody is in. The response is enormous, so the threshold is high. The threshold is high, so the response is late. Nobody designed that trap deliberately. It falls out of the arithmetic of 500,000 people and one road network. So when residents of Pozzuoli look at an alert level that has not moved in 14 years, some of what they are reacting to is not a judgment about the volcano at all. It is the recognition that the system protecting them has one enormous lever and a very strong institutional incentive never to pull it. Now let me deal with the specific claim that circulates locally, because it is a serious one, and it deserves a serious answer rather than dismissal. The claim is that the alert system has been subdivided, that additional gradations were introduced inside the existing levels, with the effect, and some would say the purpose, that the authorities can register a worsening situation without ever having to make the visible jump from one colour to the next. The factual basis for that is real. The framework in use does include subphases within levels, so that a level can be described as being at a weaker or a stronger condition, and the practical consequence is exactly as described. A system can deteriorate through a subphase without the headline colour changing. The Steelman here is stronger than people expect, so let me make it properly. A colour change is not just information. It is a trigger. It has legal consequences, it has economic consequences, it moves money, it affects insurance, it affects property values, it affects tourism, and it can compel action from bodies that would rather not act. In a place where a government minister has said publicly that they considered declaring a state of emergency and were told it would create problems for the economy and for tourism, the suggestion that there might be institutional reluctance to cross a visible threshold is not paranoid. It is an observation about how institutions work, so the criticism has weight. But notice what kind of criticism it actually is. It is a criticism of governance and of communication design. It is an argument that the way the alert system is structured lets a deteriorating situation stay quiet longer than it should. It is not evidence that anybody is hiding data, and that distinction matters enormously. Because here is the test. Every number I have cited in this video, the 1 centimetre, the 3 centimetres at Rione Terra, the drop, the uplift rate, the fumarole temperatures, the gas flux, the earthquake counts, the fact that the values are preliminary and will be revised, every single one of those came out of documents published on a schedule by the institution that is supposedly concealing the situation, weekly, with error bars, including a public commitment to publish the refined numbers next month. You cannot simultaneously suppress information and publish it in a bulletin with a stated uncertainty. If there were an intention to conceal how much the ground moved on the 31st of July, the simplest possible method would be to not calculate it. Nobody outside the institution would ever have known there was a step to look for, so the honest position on the alert level is uncomfortable in both directions. The data is not being hidden, and the framework for turning that data into public action has structural features that reduce how often anything visible happens. Both of those are true at once, and only one of them is a conspiracy. Now the sentence, the one that appears at the end of every bulletin, and which I promised earlier we would take apart. On the basis of the current picture of volcanic activity, no elements are evident such as to suggest significant short-term evolutions. Read quickly, that sounds like reassurance. It sounds like nothing is happening. It sounds like everything is normal. Read carefully, it says nothing of the sort. It is a statement about the derivative, not the value. It says the situation is not changing rapidly. It says nothing whatever about whether the situation is good. Substitute a different context and the structure becomes obvious. If a doctor tells you that your condition shows no elements suggesting significant short-term evolution, they have not told you that you are well. They have told you that you are not deteriorating quickly this week. Whether you are seriously ill is a completely separate question that sentence does not address. So apply that to the caldera. What is the condition that is not significantly evolving? It is a caldera floor rising at approximately 1 centimetre a month, in the 21st year of an unrest episode, having risen more than 1.5 meters since 2005, with roughly 1/5 of that total arriving in the last 20 months, above a hydrothermal system in a documented long-term state of heating and pressurization, with elevated emission of volcanic fluids, in rock that has been described as having passed from elastic into inelastic behaviour, beneath a town where 215 buildings are currently condemned and 500,000 people live inside the designated red zone. That is the state that is not significantly evolving. The sentence is accurate. It is also, when you unpack it, the opposite of comforting. It does not say the abnormal condition has ended. It says the abnormal condition continues at its established rate, and that this month it did not accelerate. I think this is genuinely the most useful thing I can give you out of this whole story, and it has almost nothing to do with volcanoes. Institutional language is optimized to be defensible, not to be understood. Every clause in that sentence exists to be true under scrutiny. None of it exists to leave you with an accurate emotional impression. And when the gap between what a sentence technically says and what it makes people feel gets wide enough, you get exactly what has happened in Pozzuoli, a population that has stopped believing the bulletins, not because the bulletins are false, but because the bulletins keep being technically correct in a tone that does not match the street, and the street is where we're going next. Because for 3 weeks now, the deformation this video has been describing in millimetres has been showing up in the town as something much less abstract, as water where water should not be, as rails that no longer run true, and as a harbour that has slowly outgrown the sea it was built for. Part 9, 15 leaks, and a warped railway. 1 centimetre a month sounds like nothing until you ask what it is attached to, because the ground under Pozzuoli is not empty ground. Running through it, in every direction, is the infrastructure of a functioning town: water mains, gas mains, electrical ducts, sewers, foundations, railway track. And every one of those things was designed and installed on the assumption that the ground it sits in would stay where it was put. Roberto Castelluccio is a professor of technical architecture at the University of Naples Federico II, and he is the seismic risk consultant to the municipality of Pozzuoli, which is to say, he is the person whose job it is to answer, for the town, the question of what all this is doing to the physical fabric of the place. And speaking to Italian press after the 31st of July, he laid out an inventory that reframes this entire crisis. Start with the aqueduct. The magnitude 4.7 damaged the Pozzuoli water network at multiple points. The figure he gives is around 15 separate water losses. 15 breaches in the pipes that supply a town, opened in a matter of seconds, leaving buildings without water. Think about what that means as a lived experience rather than as a statistic. In the days after the earthquake, a substantial part of the anger in Pozzuoli was not about the shaking, it was about the taps. People who had spent the night outside came back to buildings with no water in southern Italy at the end of July. When the protests came, and they came fast, continuity of water supply was one of the 3 headline demands, alongside safety and housing, not compensation, water. But the aqueduct damage from the earthquake is only the sharp edge of a much slower problem, and this is the part that connects directly back to the measurements we have been discussing. Over the past 3 years, according to Castelluccio, the ground deformation of the Bradisism has been impacting the water, gas and electrical networks. Not the earthquakes, the deformation, the slow, continuous centimetre-a-month rise that produces no shaking at all. Here is the physics of it. A buried pipe is a long rigid object anchored at intervals, at joints, at valves, at the points where it enters buildings. If the ground it is buried in rises perfectly uniformly, the pipe simply goes up with it and nothing happens. But ground deformation at a caldera is not uniform. The centre of the dome rises faster than the flanks. That means that along the length of any buried line crossing that gradient, one end is being lifted more than the other. The pipe is being bent, slowly, continuously, by a fraction of a millimetre a day, year after year. Pipes tolerate a certain amount of that. Joints have some flexibility built in, but the tolerance is finite and the deformation is not, and every year of uplift consumes a little more of the margin. So you get a network that develops leaks in ordinary weather, for no visible reason, and needs repairs that have nothing to do with any particular event. And then an earthquake arrives and finds a system that has already spent most of its slack, and opens 15 holes in it at once. The gas network deserves separating out, because the failure mode is different in kind. A leaking water main is expensive and disruptive. It floods a street, it undermines a foundation, it costs money, and it wastes water. A leaking gas main in a dense town of old masonry buildings is a different category of problem entirely, and the same slow bending that opens water leaks acts on gas lines identically. They are buried in the same ground, crossing the same deformation gradient, anchored at the same kinds of fixed points, and there is a specific reason this matters at this particular volcano more than it would anywhere else. Pozzuoli already has a gas problem that has nothing to do with the utility network. This caldera vents carbon dioxide out of the soil across wide areas. That is what the flux stations at Solfatara and Picciarelli are measuring. Carbon dioxide is heavier than air, and it pools in low enclosed spaces, basements, cellars, tunnels, undercrofts. That was the mechanism behind the railway tunnel crisis earlier in the summer. So a town that already has to think about gas accumulating in its basements from natural sources is also running a manufactured gas network through ground that is bending it. Those two problems are independent, and they can meet in the same cellar. The public advice arriving from technical experts through all of this has been the mundane, sensible kind. If you have cracks appearing in your home, do not decide for yourself whether they matter. Get a qualified technician to look at them. Which sounds obvious until you consider that a substantial part of this town has been living with cracks for years, has repaired them, has watched them come back, and has developed exactly the sort of learned indifference that advice is fighting against. The same logic applies to the railway, and here the geometry is even less forgiving. Castelluccio's account is that the railway network has been deformed by the progressive ground uplift. Rail is the least tolerant infrastructure there is when it comes to differential movement. Track has to hold gauge, alignment and level within millimetres to be safe at speed. A gentle vertical bend introduced over a few hundred metres of track is not a cosmetic problem. It is a speed restriction, an inspection regime, a maintenance obligation that recurs forever because the ground never stops moving. And the lines through this caldera are not incidental. They are the commuter railways that connect the Phlegraean towns to Naples, and parts of them run in tunnel, underground, through the very ground that is rising. That is the same tunnel system that produced a serious carbon dioxide crisis earlier in the summer, when the gas seeping from this hydrothermal system accumulated in an enclosed space to concentrations that made it genuinely dangerous. We covered that in mid-July, and it belongs in this story too because it is the same phenomenon from another angle. Infrastructure built through a volcano, being reached by the volcano. Put it all together, and you get a picture that I think is more unsettling than any single dramatic number in this video. The earthquake is the visible crisis. 215 condemned buildings, 3,500 people out of their homes, television cameras, ministers visiting. The deformation is the invisible one. It does not make the news because it does not do anything on any given day. It just quietly consumes the engineering margins of every buried system in the town, so that each successive shock lands on infrastructure with less capacity to absorb it than the shock before. Castelluccio's conclusion follows from that, and it is the most radical thing any official advisor in this story is saying out loud. He argues that what is needed is a new plan for the territory, that you cannot keep this population at this density in these buildings, in these places under these conditions, and that there needs to be a gradual redistribution of people away from the most exposed areas, naming Rione Terra and the Solfatara specifically. Read that against the geophysics for a moment. Rione Terra is the station that moved 3 centimetres. The Solfatara is where the earthquake happened. The man advising the town on seismic risk is pointing at the same 2 places the instruments are pointing at. And there is one piece of infrastructure in Pozzuoli where the deformation is not invisible at all, where you can walk down and look at it with your own eyes, and where the volcano has already won. Part 10. The harbour that outgrew the sea. The port of Pozzuoli has a problem that no amount of maintenance can fix, because the problem is not with the port. The quays have risen more than 1.5 meters relative to sea level. That is the Brady-ism made visible. Not modelled, not inferred from satellites. Just there, in the difference between where the concrete is and where the water is. The harbour was built to a certain relationship with the Mediterranean, and over the past 2 decades the volcano has been quietly editing that relationship, a centimetre at a time, until the numbers stopped working. And a harbour is nothing but relationships. That is the thing people miss. A quay is not a wall next to water, it is a precisely calibrated set of geometries, the height of the deck above the waterline so that a ramp can be lowered onto it at a safe angle. The depth of water alongside so a loaded hull does not touch the bottom. The rise and fall of the tide, which the whole arrangement has to accommodate at both extremes, raise the land by 1.5 meters, and every one of those relationships breaks at once. The ferry decks no longer line up with the quay. The loading ramps, which are designed to bridge a certain range of heights, run out of range, and under the water, where nobody can see it, the effective depth alongside parts of the harbour has been reduced, because the seabed is part of the same rising caldera floor. The land came up. The water did not. There is a second-order effect underwater that almost nobody outside the Harbour Authority thinks about, and it is arguably the more intractable one. When the land rises, the seabed rises with it. The floor of the Gulf of Pozzuoli is part of the same caldera, and it is part of the same dome, so the deformation does not stop at the waterline. That means the working depth alongside the quays has been shrinking for 20 years, and unlike a quay deck, you cannot shim a seabed. You dredge it, repeatedly, expensively, forever, or you accept that fewer and deeper drafted vessels can use the port. That is the direction the operational decisions have been drifting for a while now. Move the bigger movements to Naples. Keep Pozzuoli for what still fits. Use a floating structure for what does not. And there is a strange historical rhyme in that, because this stretch of coast has been through the reverse of it before. Just around the headland from Pozzuoli lies Baiae, which in the Roman period was one of the most fashionable resort towns in the empire. Villas, thermal baths, marble everywhere. A large part of it is now under the sea, submerged by the same Brady-ism running in the opposite direction, and today it is an underwater archaeological park where divers swim over mosaic floors. So this caldera has already taken one harbour town down beneath the waves, and is currently lifting another one out of the water. Same volcano, same process, opposite sign. And the columns of the Roman market at Pozzuoli, with their band of mollusk borings partway up, are the receipt for the whole cycle. The difference is that the Romans did not run a scheduled ferry service with a fixed loading ramp. For a town whose harbour is a working transport link, that is not an inconvenience. Pozzuoli is one of the main departure points for the islands of Ischia and Procida. Those islands run on the ferries, for people, for cars, for freight, for the food in the shops. The harbour is not scenery. It is a supply line. By the middle of July 2026, The situation had reached the point where a physical intervention was required, and the solution deployed is one of the most striking things in this entire story. They brought in a floating platform. It is called Campania, and it went into operation at the Emporio Ovis Quay in mid-July, specifically to mitigate the effects of the Bradycism and keep the port workable for the island ferry connections. And the logic of it is beautifully simple and slightly absurd. If the fixed quay has risen out of alignment with the ships, then use a quay that is not fixed. A floating structure sits on the water. It does not care what the land is doing. Whatever the caldera does next, the pontoon will still be at sea level, because sea level is the one thing in Pozzuoli that is holding still. I want to underline what that represents, because I think it is the most quietly remarkable engineering decision in this whole crisis. That is a town giving up on the ground. Not dramatically, not with an announcement, just an operational decision that the land can no longer be treated as a stable reference surface, and that anything requiring a fixed relationship with the sea has to be decoupled from the land entirely. That is not disaster response. That is adaptation. The acceptance that this is not an event to be recovered from, but a condition to be lived with, indefinitely. Then the 31st of July arrived and added the acute problem on top of the chronic one. The earthquake damaged the quay and the port was closed. Ferry services to Procida and Ischia were cut. For a day, the islands lost one of their main links to the mainland, in the first week of August, in the middle of the Italian holiday season, which is the single worst week of the year for that to happen. The port was reopened quickly, by a maritime authority ordinance issued on the 1st of August, restoring access, the transit of people and vehicles, and port and commercial activity both on land and on the water. That is fast work, and it deserves to be said, because a great deal of this story is about things not happening fast. But reopening the port did not solve the underlying access problem, and this is where the two crises braid together into something genuinely difficult. Heavy vehicles are restricted. The routes that lorries would use to reach the quay run through the affected town, past buildings that are damaged or condemned or under assessment, and you cannot send a fully loaded articulated truck down a street with an unstable facade on it. So the restrictions stayed in place. And the consequence of restricting heavy vehicles at a ferry port is that you have restricted the goods. By the third week of August, this had escalated into an open confrontation. There was a formal threat to suspend food supply operations from the 21st of August, unless a solution was found. The proposals on the table included moving all the ferry routes away from Pozzuoli to Naples entirely, or granting temporary exemptions to let heavy vehicles cross the restricted roads at reduced speed. Follow that causal chain all the way back, because it is worth seeing whole. A magma or fluid source several kilometres underground is supplying something upward. That pushes the caldera floor up by a centimetre a month. 21 years of that raises the quays of the harbour above their design relationship with the sea. A separate consequence of the same process, a brittle lid failing under the accumulated pressure, produces an earthquake, which condemns buildings along the streets leading to the harbour, which means lorries cannot reach the quay, which means the islands of Ischia and Procida have an argument about their groceries. There is no point along that chain where anybody did anything wrong. It is just a volcano, doing what it has done since before the Romans built a market at Pozzuoli, arriving in the 21st century and finding a supply chain in the way. And that is the register this crisis actually operates in. Not lava, logistics. Now, the port and the pipes and the railway are inanimate. They can be shimmed, replaced, rerouted, floated. The harder question is what 21 years of this does to the people who live on top of it, and 3 weeks after the 31st of July, that number was still going up. Part 11. Building for a ground that will not stop. Every engineering response we have just looked at shares one feature, and once you notice it, you cannot unnotice it. None of them has an end date. The floating pontoon is not a temporary measure until the quay comes back down. The quay is not coming back down. The repairs to the aqueduct are not a fix. They are the latest instalment in a maintenance obligation that renews itself every year the ground keeps moving. The speed restrictions on the railway are not a phase. The heavy vehicle limits are not a phase. Every one of these is an adaptation to a condition, not a recovery from an event. And that is the point where this stops being a story about an earthquake and becomes a story about what it means to live on a volcano that is not erupting and is not stopping either. Castelluccio's argument follows directly from that recognition. and it is worth stating in its strongest form because it is the most consequential idea anyone in an official advisory role is currently putting into the public conversation. His position is that the density of population in the most vulnerable areas is itself the problem, and that what is required is a new plan for the territory, a gradual redistribution of people away from the most exposed places, with Rione Terra and the Solfatara named specifically. Not an evacuation, not a panic, a managed, deliberate, long-term thinning of the most exposed ground. Now hold that against the numbers from the first half of this video. Rione Terra is the station that recorded 3 centimetres of horizontal displacement, sitting on the crest of a dome that has risen more than 1.5 meters. The Solfatara is where the largest earthquake ever recorded at this caldera nucleated, 3 kilometres down, in the lid of the hydrothermal system. The seismic risk consultant and the satellite receivers have independently identified the same 2 locations, one from 21 years of position data, the other from 20 years of walking around the town looking at buildings. That convergence is the strongest argument in this entire story, and it is also the one least likely to be acted on, because it asks the hardest possible thing. Everything else on the list, the pontoon, the pipe repairs, the track inspections, the lorry restrictions, is a technical problem with a technical answer and a budget line. Reducing how many people live in a particular neighbourhood is not a technical problem. It is a political one, and it runs against everything about how a town like Pozzuoli works. Family homes held for generations, property that represents most of a household's wealth, a community that has already been moved once in the 1980s and does not want to be moved again, and a local economy that depends on people being there. Which is precisely why the argument keeps being made and keeps not happening, and why the red zone has actually expanded over the years rather than emptied. And the direction of travel over the last few years has been the opposite of thinning out. The red zone has grown. The area designated for evacuation in the event of a full alert used to be a smaller footprint. It has been expanded to take in more of the Phlegrean municipalities, Pozzuoli, Bacoli, Quarto, Giugliano, and it now reaches into Naples itself, covering neighbourhoods on the western side of the city. Which is not a mistake. It reflects better science. As the understanding of the caldera's structure has improved, the area that would be affected by a serious event has been drawn more honestly. But look at what that means in practice. Over the same period in which volcanologists have been arguing for fewer people in the exposed zone, the number of people officially designated as being in the exposed zone has gone up, because the zone got bigger while the population stayed put. That is not a failure of anybody's intentions. It is what happens when a hazard assessment improves faster than a housing policy can respond. The map got more accurate. The town did not move. There is a version of this that I think gets missed in the coverage, and it is the version that connects it all back to what the instruments recorded on the 31st of July. Every one of these adaptations is a bet on the rate. The pontoon works if the ground rises a centimetre a month. The pipe repairs are affordable if the ground rises a centimetre a month. The inspection schedules, the maintenance budgets, the whole architecture of coping is calibrated on the assumption that the ground carries on doing approximately what it has been doing. And what the 18th of August bulletin told us, in the most understated way possible, is that the ground is carrying on doing approximately what it has been doing. The largest earthquake in the recorded history of this caldera did not change the rate, which means the adaptations remain valid, and it also means they remain necessary indefinitely, with no mechanism in sight that would end them. The engine is still running. That is simultaneously the reassuring news and the exhausting news, and the town has to hold both at once. But infrastructure can be adapted to indefinitely. People are harder, and 3 weeks after the earthquake, the number of people who could not go home was still going up. Part 12. 3,627. Here is the sequence, and I want to give it to you as a sequence rather than as a single figure, because the movement is the information. On the 19th of August, the municipality of Pozzuoli had issued 367 evacuation orders. Those orders affected 1,391 family units. 3,488 people were being assisted. On the 21st of August, 2 days later, the figures were 408 evacuation orders, 1,443 family units, and 3,627 people displaced. 41 more orders, 52 more households, 139 more people, in 48 hours, 3 weeks after the shaking stopped. That is the number that tells you what kind of disaster this actually is, because earthquakes are instantaneous. The rupture on the 31st of July lasted a matter of seconds. Everything that was going to break broke that night, and yet the count of people who cannot go home was still climbing 3 weeks later at a rate of about 70 people a day, and there is no sign in those figures of it having stopped. The reason is not that the volcano is still doing damage. The reason is that the constraint is not seismic, it is administrative. Every one of those additional evacuation orders is a building that somebody finally got round to inspecting. There were 1,486 fire brigade interventions logged by the 21st of August, with 21 squads still working. Each intervention is somebody in a helmet walking into a damaged building, looking at what the walls are doing and making a judgment. That process is rate limited by how many qualified people you can put in the field. So the true footprint of the 31st of July is not yet known, 3 weeks on, and will not be known until the inspection curve flattens, which has a very awkward implication for policy, and we will come to it. Every measure designed and costed on the early numbers was designed for a smaller disaster than the one that exists. Let me fill in the rest of the ledger, because the composition matters as much as the total. 215 buildings have been declared uninhabitable, accounting for 1,085 housing units. Divide one by the other, and you get just over 5 dwellings per condemned building. That is the signature of a multi-storey, multi-family housing stock. Apartment blocks, not detached houses. It is why 408 orders produce 1,443 households. One order can empty a whole building. 9 revocation orders have been issued. 9 buildings cleared for return, against 408 condemned. Of the displaced, 3,459 are in what is called autonomous accommodation, meaning they have found somewhere themselves, usually a rental, usually with relatives, usually at their own initiative. 143 are in hotels, 53 are in a sports hall. 19 places of worship have been declared uninhabitable, and there is an operation running with the fire brigade, the heritage authorities and the diocese to secure and remove artworks, furnishings and other cultural property from them. Non-structural repair work is underway on 7 municipal school buildings and 4 institutes run by the Metropolitan Authority, with the start of the school year approaching. The ratio of 408 condemnations to 9 revocations is worth pausing on, because it tells you something about how these assessments work that is not obvious from outside. A habitability assessment after an earthquake is not a repair estimate. It is a safety judgment about whether it is acceptable for people to be inside the building right now, made quickly by people who will be held responsible if they get it wrong. The default under uncertainty is to condemn, and that is correct. The cost of wrongly declaring a sound building unusable is inconvenience and expense, and the cost of wrongly declaring a damaged building safe is that it comes down on somebody. But the asymmetry runs the other way when it comes to clearing a building for return. Condemning is fast because visible damage is enough. Uncondemning is slow because it requires establishing that what you can see is not concealing something you cannot. And in an unreinforced masonry building, the load-bearing behaviour is genuinely hard to assess without opening things up. That is why 9 families have gone home against 408 orders, with checks in progress on a few dozen more units. It is not obstruction, and it is not indifference. It is the arithmetic of a conservative safety process applied to a building stock that is difficult to certify, which is also, incidentally, why the promise that people will return in safety rather than merely return quickly is not a rhetorical flourish. It is a technical commitment with a very long completion time. Now let me deal with the objection, because I know it is coming and I think it deserves a real answer rather than a dismissal. A magnitude 4.7 and thousands of people out of their homes. If you live in California or Japan or Chile, that ratio looks absurd. 4.7s happen constantly in those places and nobody so much as puts down their coffee. It is not absurd, and there are 3 separate reasons why, and they compound. The first is depth. This earthquake was about 3 kilometres down. Most crustal earthquakes you hear about are 10, 15, 20 kilometres deep. Shallower means less rock between the rupture and the surface for the energy to spread out through, which means the shaking directly above the source is far more intense than the magnitude alone suggests. Magnitude measures energy released at the source. It does not measure what arrives at your building. At 3 kilometres, a great deal arrives. The second is the building stock. Much of the affected housing in Pozzuoli is old masonry, brick and stone with mortar between it. Structural engineers who have looked at this stock describe buildings in which the mortar has degraded so far that the structures are effectively leaning against one another rather than standing independently. That is not a design code failure. Most of these buildings predate any meaningful seismic code, in some cases by centuries. They were built for gravity, not for lateral shaking. The third is cumulative loading, and it is the one people almost never account for. A building does not reset between earthquakes. Every event that cracks a wall leaves that wall weaker, stiffer in some places and looser in others, with existing fracture planes that concentrate stress the next time. Pozzuoli has now been shaken repeatedly, over years, by a ladder of earthquakes climbing through the magnitude 4s. There are residents who repaired damage from an earlier event only to have the 31st of July reopen exactly the same cracks and take the building out of use entirely. So the honest comparison is not between a 4.7 in Pozzuoli and a 4.7 in Los Angeles. It is between a 4.73 kilometers beneath a town of degraded historic masonry that has already been shaken 100 times and a 4.715 kilometers beneath a city built to a modern code that has not. 215 condemned buildings is not a mystery. It is the arithmetic of that comparison. And a great deal of the anger in Pozzuoli comes from the fact that every one of those three factors was known in advance and had been pointed out for years. Part 13. The contribution that doesn't buy a house. There is a mechanism in Italian emergency law called the contribution for autonomous accommodation. In practice, it means that if you are ordered out of your home, the state pays you a sum to go and find somewhere else to live, rather than housing you directly. On paper, it is a good instrument. It is faster than building anything. It respects people's agency. It keeps families near their schools and their jobs and their relatives instead of concentrating them in a camp. In Pozzuoli in August 2026, it is running into two problems at once. The first is throughput. As of the 19th of August, 1,207 applications had been submitted. 726 households had been paid. 481 applications were still outstanding, somewhere between assessment and payment. That is 40% of applicants unpaid, 3 weeks after the event, and these are not people waiting for a windfall. These are people who have already left their homes and are already paying rent somewhere else, out of their own money, while the reimbursement works its way through. The second problem is the one the money cannot solve, and the civic network in Pozzuoli has put it more sharply than I could. An economic contribution does not automatically guarantee a house. That is the sentence, and the arithmetic behind it is brutal. You have just created demand for over 1,400 rental properties, simultaneously, inside a narrow geographic area, in one of the most housing-constrained parts of Italy, in the middle of the tourist season, on a coastline where a large fraction of the available stock is short-term holiday letting. The supply is not there, and where it exists, prices have reportedly risen substantially, which means a contribution calculated against pre-crisis rents does not cover post-crisis rents. So the contribution can be paid in full, on time, at the correct rate, and a family can still be unable to find anywhere to live within reach of the school their children go to. That is the gap the network Pozzuoli Assiste Ancora, Pozzuoli still exists, has organised itself around, and their framing of it is worth quoting properly because they have thought about this more carefully than most of the coverage has. Since the 31st of July, they say, there has been an urgency in Pozzuoli that comes before every other discussion. More than 3,000 people have been forced to leave their homes and risk becoming invisible. Invisible is the operative word. A displaced population in autonomous accommodation is a displaced population that does not appear anywhere. There is no camp to film. There is no queue outside a shelter. 3,459 people are scattered across rentals and spare rooms and relative sofas across the whole province, and from the outside the town looks like it is functioning. They have put 4 specific proposals on the table, and they are notably practical rather than rhetorical. The first is to tie the accommodation contribution to a controlled rent mechanism, so that rising market prices cannot simply absorb the public money and leave the family no better off. The second is to identify sites inside Pozzuoli itself for dignified temporary housing, as the emergency planning already provides for, while explicitly rejecting any repeat of the shanty settlements that followed earlier disasters in the region. The third is to steer the agreement between the regional government and the Hoteliers Association toward accommodation closest to the Phlegraean area, rather than wherever rooms happen to be available. The fourth is to prioritise the public housing stock that does exist for the evacuated households containing children, people with disabilities, and other vulnerable members. That business about minor building irregularities is worth a sentence of its own, because it is the sort of bureaucratic detail that decides whether a policy actually reaches anybody. Italian residential property frequently carries small discrepancies between what is built and what is on the official plans. An enclosed balcony, a converted space, a wall moved decades ago. Public funds for repair generally cannot be disbursed to a property that is not fully compliant. So a family whose home was condemned by an earthquake can find themselves ineligible for the money to repair it because of a partition their grandparents moved in 1970. That is why simplification of procedures keeps appearing on the demand list alongside the money itself. Underneath all four is a single objective which they state directly, and which is the thing that separates this from an ordinary housing crisis. The aim is not simply to find people somewhere to sleep. It is to prevent the emergency from permanently dispersing the community. That is the real risk here, and it is worth understanding why. If people cannot find housing in the Phlegraean area, they will find it elsewhere, and elsewhere is where their children will end up enrolled in school, and where the second year's lease will be signed, and where the family will still be in 5 years. Displacement that lasts long enough stops being displacement and becomes migration. A town can survive an earthquake. It is much less obvious that a town survives its own population, quietly relocating one household at a time over 18 months. There is legislation moving. A decree law was published on the 7th of August and came into force on the 8th, containing specific provisions on the accommodation contributions and on the repair and seismic requalification of uninhabitable residential buildings in the Campi Flegrei. It still has to be converted into law by Parliament, which means the text can be amended in passage, and given that it was drafted in the days immediately following the earthquake, when the displaced count was a fraction of what it is now, amendment is exactly what the people in Pozzuoli are asking for. Their position on the wider political argument is more restrained than you might expect, and it is the reason I take them seriously. On the question of whether a formal state of emergency should be declared, they decline to make it an ideological fight. Their argument is procedural. Establish first what measures the Campi Flegrei actually need, what resources have to be guaranteed, and what powers are required, and only then argue about which legal instrument delivers them. And their statement of what the goal is deserves the last word in this section, because it reframes the entire crisis in one sentence. Normality, they say, cannot simply be going home as soon as possible. Real normality is being able to return in safety, which is a much harder thing to deliver at a volcano that is still rising. Part 14. The funds are there. On the 4th of August, around 2,000 people marched through Pozzuoli. They were displaced residents, and residents of the historic centre who still had no water and no electricity, and people who simply lived there and had reached the end of their patience. The march ended at the port, and a quay was occupied, and the ferries to the island stopped. It lasted about an hour. Banners read out quickly, and we are not squatters. That second one aimed squarely at any suggestion that people demanding housing were asking for something they had not earned. The demands were 3: safety of the territory, stability of housing, and continuity of the water supply. The occupation ended when the prefect of Naples secured a commitment that a delegation would meet the interior minister directly, the following day, in Naples. I want to note what that sequence actually demonstrates, because it is easy to read a port blockade as pure anger and miss what it accomplished. A community that had been asking for attention through official channels for 3 weeks got a ministerial meeting within 24 hours of stopping the ferries. That is a lesson about how visibility works, and it is not a flattering one for the official channels. Since then, the mobilisation has continued and matured. There was a public assembly on the 12th of August that gathered proposals to take to the coordination table at the prefecture. The demands that have come out of it are detailed and unglamorous: extension of the contributions, full coverage of repair costs, simplification of the procedures, a solution for the minor building irregularities that can disqualify a property from receiving public money, comprehensive building inspections, support for businesses and workers, specific measures for the displaced, and greater transparency about what the Special Commissioner is actually doing. That is not a mob. That is a policy submission with a banner. And the frustration has reached the political level, which is where it gets genuinely revealing. Pozzuoli is another of the red zone municipalities at the far western end of the caldera. Its mayor, José Gerardo della Ragione, has been publicly and repeatedly critical of the pace of the response, and his central complaint is not the one you would expect. He is not saying there is no money. His formulation is this: the funds are there. The problem is spending them and starting construction sites. He has said that despite 11 million euros allocated, work has not started. He has called for acceleration of the seismic vulnerability assessments and for economic support so that adaptation work on private buildings can actually happen, announcing immediate verification of the vulnerability of private buildings, with the works to be paid for in part from public funds. And he has framed the underlying failure as one of sequencing. Decrees arrive after the earthquakes, when what is needed is prevention. There has also been local scrutiny of how the money already allocated has been used. A municipal document transmitted on the 13th of August reported 499,500 euros designated for urgent measures for the seismic requalification of uninhabitable residential buildings, with public pressure on the administration to explain why the sums had not been committed. I am not going to adjudicate that. Local funding disputes are local funding disputes, and I do not have the accounts in front of me. But the shape of the complaint is consistent across every part of this story, and the shape is what matters. Announcements of large sums, followed by a conspicuous absence of anything happening on the ground. There is one more piece of political context that hangs over all of this, and it has been in the public record for a while now. A government minister with responsibility for civil protection said publicly that he had considered it appropriate to declare a state of emergency for this area, and was told that doing so would create problems for the economy and for tourism. The same minister had earlier said that if a magnitude 5 earthquake were to occur here, we will count the dead, a statement that drew heavy criticism at the time, and which reads very differently now that a 4.7 has condemned 215 buildings. I am not going to construct a conspiracy out of that. A minister saying out loud that he was blocked is the opposite of a cover-up. It is a politician putting an internal argument on the public record. But it does establish from the inside that the tension between declaring the situation serious and the economic consequences of doing so is not something residents invented. It was described by the person it happened to, and here is where this connects straight back to the geophysics, which is the reason it is in this video at all. Everything in the political argument is running on the timescale of an emergency. Decrees drafted in days, contributions paid or not paid in weeks, ministerial meetings secured by blocking a harbour for an hour, figures updated every 48 hours. The volcano is not running on that timescale. The volcano is running at a centimetre a month, and it has been running at approximately that rate for 21 years. And the single most important finding in the 18th of August bulletin is that the largest earthquake in this caldera's recorded history did not alter that rate by any amount the instruments can distinguish from noise, which means the mismatch is structural. Emergency instruments respond to events. This is not an event. The 31st of July was an event, and it produced an emergency response, and the emergency response is now working through the consequences of that one night. But the thing that caused the 31st of July did not begin that night, and did not end that night, and there is no measurement anywhere in any bulletin that suggests it is going to end on the timescale that decrees and contributions and construction contracts operate on. Della Ragione's point about prevention is exactly this point, stated by somebody who has to live with it. You cannot keep responding to a continuous process with discrete interventions triggered by its occasional visible outputs. Every time you do, you are calibrating on the last output rather than on the process, which is precisely what happened with the measures drawn up on conditions that predated the 31st of July, and why the newest damage did not fit inside them. The ground moved 3 centimetres at Rione Terra on the 31st of July, and then went back to rising a centimetre a month. The response is still, 3 weeks later, catching up with the 3 centimetres. Part 15. A centimetre. A month. Before I close this out, I want to give you 2 reference points for the numbers we have been handling, because a centimetre and 3 centimetres are hard to feel, and comparison is the only way I know to fix them in place. The first is a comparison in the other direction, and it is deliberately extreme. In 2025, a magnitude 8.8 earthquake struck off the Kamchatka Peninsula in the Russian Far East. That is a megathrust event, near the top of what this planet can produce, and its co-seismic effect was to move the peninsula. Not a station on the peninsula, the peninsula. Ground displacement from an event of that class is measured in meters over a rupture that runs for hundreds of kilometers, and the whole geometry of a landmass shifts. So when I tell you that Campi Flegrei produced 1 to 3 centimetres of permanent offset, I am telling you it produced something several hundred times smaller than that, from an earthquake that released very roughly 100,000 times less energy, which is exactly why it matters that anybody measured it at all. An 8.8 moves a peninsula, and you would detect that with almost any instrument you cared to point at it. A 4.7 producing a permanent, coherent directional offset of 1 to 3 centimetres across a monitoring network is right at the edge of what is measurable. And the only reason it was measured is that this particular caldera has been carrying 21 years of continuous, patient, boring geodetic monitoring, so that when a step appeared, there was a 2-decade baseline underneath it to prove that a step was what it was. There are volcanoes all over the world that have done exactly what Campi Flegrei did on the 31st of July, and nobody will ever know, because nobody was watching that closely. The second reference point is a date, 1538. That is the last time this caldera erupted, and what it produced was not, by volcanic standards, a catastrophe. Over roughly a week, an eruption near the coast built a new hill, Monte Nuovo, the new mountain, and the name is exactly as literal as it sounds. It stands about 130 meters high, and you can walk up it today. On the scale of what this caldera has done in its deeper past, it was tiny. What preceded it is the part that keeps getting cited, and the part that is genuinely uncomfortable. The eruption came at the end of a long period of ground uplift in the same area. Accounts from the period, and the geological reconstruction since, describe several meters of rise in the years and decades beforehand, with a sharp acceleration in the final stretch. The sea withdrew from the shore, new land appeared, and then the ground opened, several meters. We're currently at something in the region of 168 centimeters since 2005, which is well under 2 meters, which cuts both ways again, as everything at this volcano does. On one hand, the current uplift is a fraction of what preceded the last eruption, and that is a real and legitimate reason not to panic. On the other hand, the last eruption was preceded by uplift, and the uplift is what we are watching, and it has not stopped. That is the entire epistemological situation at Campi Flegrei in one comparison. The precedent tells you what the pattern looks like. It does not tell you where in the pattern you are. So let me pull the whole thing together. On the 31st of July, 2026, the floor of the most closely monitored caldera on Earth moved sideways, about a centimetre for most of the central network, in a predominantly southwest direction. About 3 centimetres at Rione Terra, in the middle of Pozzuoli, at the crest of the dome, toward the south-southwest. And the same ground dropped by 1 to 2 centimetres. Every one of those numbers carries an error bar of plus or minus 2 millimetres, and every one of them was published by the institution that measured it, along with a note saying they are not final and a commitment to publish better ones next month. That is the finding, and in 21 years of this crisis it is the first time the caldera floor has been recorded doing anything like it. And then the ground went back to rising, at approximately 1 centimetre a month, exactly as it had been. No detectable change in the pattern, once the step was corrected out. The largest earthquake ever recorded at this volcano registered in the deformation data as a discontinuity to be removed so that the underlying trend could be read cleanly. The rock broke, and the thing pushing on the rock did not notice. What I keep coming back to is that this is the opposite of the story anybody expected to be telling 3 weeks ago. When the earthquake happened, the question everyone asked was, what does this mean? Is this the beginning of something? Has the volcano changed? And the answer that came back from the instruments slowly, over 3 weeks of recalculation, was no, nothing changed. The pattern that was here before is still here, at the same rate, in the same direction. The volcano did not escalate. It also did not calm down. It did not respond at all. Meanwhile, up on the surface, everything changed. 215 buildings condemned, 3,627 people out of their homes, and the number still climbing 2 days at a time, an aqueduct with 15 holes in it, a railway that no longer runs true, a harbour loading its ferries off a floating pontoon because the land came up and the sea did not, 19 churches emptied of their artwork, schools being patched before term starts, 2,000 people on a quay in August demanding water, all of that from one night, and underneath all of it, unchanged, indifferent, and entirely unbothered by any of it, a centimetre a month. That is what I find genuinely difficult about this story. Not the drama of the earthquake, the absence of drama underneath it, a town in crisis sitting on a process that has not so much as flinched. There is one thing that would change the picture, and it is not an earthquake, it is a document. Sometime in the coming weeks, the monthly bulletin for August will be published. In it will be the definitive recalculation of those co-seismic discontinuities, the final numbers computed with the final satellite orbits with the corrected time series behind them. It will either confirm 1 centimetre and 3 centimetres and the drop, or it will revise them, and buried inside it will be the answer to a question nobody has published yet. Because right now, that 3 centimetre offset at Rione Terra is a step in a graph. What we do not know is whether it is going to stay there. Ground that jumps during a rupture very often creeps partway back over the following weeks and months, as the stresses around the fault relax. If the offset holds, then the oldest part of Pozzuoli has been permanently moved 3 centimetres toward the sea, and that is a piece of tectonics that is now simply true and always will be. If it creeps back, then part of what we watched was elastic, and the caldera absorbed more of that night than it first appeared to. Same measurement, 2 completely different meanings. So the question I am left holding, 3 weeks after the ground under Naples moved for the first time in 21 years, is not whether this volcano is going to erupt. Nobody can answer that, and anybody who tells you otherwise is selling something. It is much smaller and much more answerable than that, and it is the thing I will be watching for. Did Rione Terra stay where the earthquake put it,